Welcome to the final feedback session of your physical IPE paper. So this session will be on the water section. Now in your real A-level, you will actually have a combined water and carbon cycle section worth 49 marks. But because we have not yet completed carbon, we've about 10 lessons left of it, we just did water for 49 marks instead in your IPE. So you will not have 49 marks worth of only water questions. There will be a mixture of water and carbon questions together. As you can see on screen, you will always have a 3-mark resource question, and a 6-mark question, and an 8-mark question, and a 12-mark question, and a 20-mark question as well. So let's start. You can see here on screen are 2 of the resources that were given to you in the exam to use to answer the exam questions. On the left is a graph to show the water budget of a river in California in 2016. And on the right is predicted water stress by 2014 on the core left map. So, question 4A. Study figure 4A and explain the relationship between precipitation and soil moisture. Now, a lot of you got 2 or 1 in this answer because I genuinely think you did not quite know what to do with the explain bit. You kind of said what was in the graph and that was it. So let's go back to basics of this and look at the graph first. The graph is showing you precipitation in blue. The highest precipitation months there are January to April and October to December. Then evapotranspiration, so evaporation from trees, plants, soil, etc. From January to May, they are at the highest rate, and then again in November and December. So there is a link there straight away. When precipitation is high, evapotranspiration is rising. When precipitation falls, there's a slight lag, and just behind it, evapotranspiration also falls. There's less water overall in the hydrological cycle. We've also got, for each of the months categorized below there, soil moisture surplus and utilization and deficit and recharge. And that's the kind of stage that the water cycle goes through, or the soil moisture goes through in the water cycle. So, explain the relationship between precipitation and soil moisture. This sample answer got 3 marks, and it did so because of this. It says, figure 4A shows that when there is more precipitation, there are higher levels of soil moisture. This is because when it rains, the fluxes in the hydrological cycle, such as infiltration, ensure that the water reaches the soil. Excellent. 2nd mark, brilliant. Use of key terms, linking it to the water cycle, perfect. However, during a dry period, soil moisture decreases due to increasing levels of evapotranspiration. What that candidate is saying is, during this dry period here, particularly of April, May, and June, where rainfall falls quite low and evapotranspiration is high, a dry period occurs, and therefore there is less for evapotranspiration to take place, less water overall. So, key to success. Clear link between precipitation and soil moisture, and full explanation. In these 3-mark questions, it's really important that there's always a number of ways to get maximum marks. You only need to write one explanation, as this candidate has done, to gain maximum marks. Explaining all of the 4 moisture states would still gain 3 marks, but you do not have to. You only need to pick out what the link is. So, for you then, for your MRI, a lot of you will be doing this one. Content to include. Link the factors of precipitation and evaporation together. What's the trend or pattern you see between the 2 of them? Use data if you want to prove what you're saying. Explain why the trend is happening. And finally, you can say things like soil is moisturized or is saturated between January and May. And we know that because there's been a high amount of rainfall and evapotranspiration is high. But as precipitation falls, evapotranspiration rises, and evapotranspiration causes a drier period in the deficit. Okay, so here. Now, please use that sample answer to guide you in answering it yourself. Next question, question 4B. Explain why land use can change or increase flood risk. This links to a question in your code section where we mentioned that you could talk about urbanization as an increasing flood risk along a coastline. Actually, this is very similar to what this question is asking. Explain why land use changes can increase flood risk. Most of you answered this pretty well, actually. There were lots of references to urbanization. That's really good. And so this answer on screen here for you achieved 5 out of 6. Okay. Sorry, 6 out of 6. It achieved full marks. So this talks about deforestation and agriculture. So removing trees and removal of plants causes more of the ground to compact and increasing through flow in the soil. This means that water can travel over pretty quickly and increase the flood risk. And also then urbanization, urban environments. Obviously, if you build impermeable surfaces on the soil, like concrete or cement, then the water can't infiltrate anywhere. So surface runoff takes place, the water sits on the surface, drainage systems like drains fill up, and more flooding takes place. So a pretty simple answer, really. And as I said, this scored full marks. Range of accurate information, fully developed. With this question 2019, the common theme from the examiner's report was that you needed to read the question very carefully. You did not just need to talk about surface runoff and how that increased. Actually, you needed to talk about how flooding increased. Yes, surface runoff is part of that, but it's about land use changes mainly. Content to include, I would talk about land use changes increase flood risk through urbanization, deforestation, or agriculture, whatever you prefer. You can say that they all decrease lag time on a hydrograph. So if you build an urban area, the hydrograph lag time will be longer because it takes longer for the water to infiltrate through cement and concrete and so on. You can talk about permeable and impermeable surfaces and how that impacts infiltration and surface runoff. You can say how drainage systems in urban areas can be overflowing, and that increases even more risk. And also, you could talk about the removal of trees and how that decreases interception rates, and that leads to higher surface runoff, and that leads to more flooding. So that is question 4B. Most of you answered that pretty well. Some of you will need to redo it though. Question 4C. Explain why the price of water varies globally. Now, this question requires you to say more than just the reason price of water varies globally is because of wealth and availability. That is not the answer. That would be a very basic GCSE answer. You need to use specific examples here, and you need to explain the link between the price of water and different physical and human factors. So the answer on screen for you was an answer that gained the full 8 marks, and it is also an answer that uses examples particularly well. So let me just run through what this candidate said. So this candidate said that water in the UK costs around 10 cents US cents per 50 litres, whereas in nations such as Tanzania, it costs $2 per 50 litres. So this is due to things like availability, poverty, government strategies, etc. Then the candidate goes through Coca-Cola as an example, how they use water and how that affects the price of water. It talks about water scarcity on the map. It talks about Chad and how that has a high water scarcity. It talks about Tanzania again and how that has a high water scarcity. And it talks about how the government may not have the funds or technology to drill deep down into underground to get that extraction of water, and therefore prices are higher. And then it finally talks about governance and how that can vary the price of water. So it uses the example of Singapore. Singapore were trying to combat excessive water usage, so they've come up with strategies to eliminate water waste, and they have managed to do that. And they've also talked about over abstraction in California and how that's led to higher prices in California because too much water has been taken from the ground and there is less availability. So You do not need to use that many examples. However, this candidate has really successfully answered the question through use of examples only. So, a really varied response, really well developed. But remember, the number of lines on the question paper is the length of response required. A lot of you used half the amount of space you should have here. Okay? So use the recommended length. That is the length of the answer should be. Content to include. Saying that high water availability means low water prices is nowhere near good enough. As I said earlier, you need to look at the reasons for water price availability, such variability, such as the physical availability itself, poverty, government strategy, water conservation strategies, water processing techniques, over abstraction, climate conditions, etc. And finally, you can use case studies that are really useful, such as that Coca-Cola one in this answer. You can actually directly use that from her answer or his answer if you want to. And you can use the map to look at countries such as Chad and other countries that are experiencing high levels of water stress and will have higher prices of water. Okay, so that is question 4C complete. Question 4D. So, question 4D is a 12-mark question. It's an assess question, and it asks you to look at figure 4B, which is in front of you on screen now, and it asks you to assess the role of physical factors in influencing current or future water stress. This is linked to the previous question in a way because it's asking you what physical factors influence water stress in future. So if you have a look at the map, we can see that the extremely low areas of water stress are all around the tropics. Why? Because the tropics receive a higher amount of rainfall. The extremely high areas of water stress are in southern Europe and North Africa, and most of the Middle East and South of Asia and Central Asia. The reason these have high or extremely high levels of water stress are twofold. One, possibly because of very high amounts of population. Two, possibly also because of a large lack of availability due to the climate in those areas. So, as we know, Morocco, for example, Libya, and so forth, these areas receive very minimal amounts of rainfall but have high populations. So, that might be why in 2040 they're predicted to have high water stress. So, this answer on screen got 12 marks. So, got the full 12 marks. I'm going to run through now what the answer argued about. So it outlined the water stress means not having enough water to satisfy demand, and it can be caused by both physical and human factors. It says that the pattern shows that extremely high levels of water stress are in North Africa and the Middle East, the US and Australia, and so forth. It said that physical factors such as climate, weather, and location play a role, but also that humans play a role. Population density, demand for economic development play an important role too. So this answer is going to argue basically that whilst physical factors are really important, human factors are also important. The answer then goes through the map and just explains briefly the areas that have extremely high water stress and they're prone to drought. It links it to climate. It talks about how underground aquifers are probably low. It talks about how ensocycles, it links climate ensocycles in here in the Pacific, changing weather every few years across the tropical regions and the areas of high water stress. So that's all the physical factors. And then it says, however, or on the other hand, human factors also play a role. So it talks about predicting water stress based on demand. It talks about the need for more because of rapidly growing populations, rapidly increasing demand due to technology. And it talks about then linking as well as drought and climatic factors to those physical or human factors. Okay. So it links the physical and human factors here together. And then at the end, it just says overall, basically, climate and geographic location show that they are a big problem and physical factors do play a massive role and they do contribute, but also you've got the human factors playing a role as well, and they sometimes support each other to make the problem even worse. So, that answer then Really useful in terms of its knowledge and understanding, really logical, coherent ideas, good structure, good both sides of the argument in there. Um, Good importance range in there as well, which is really important. An excellent assessment. It brings in the enzo cycles, which is really rare to see. This student has done really well. And so I got the full 12 marks. And finally, for when you are redoing this question, content to include. Physical factors like climate change, El Nino events, over abstraction can lead to higher costs and leads to more water stress. And that's a human factor. Good use of the map. Make sure you use the map very clearly to identify particular areas. You could use case studies here that we've studied. So you could talk about China or India and the Mekong, or you could use the Middle East and you could talk about the Nile as well if you wanted to, and how the water stress in those areas are high as well. And finally, as I mentioned just a minute ago, the importance factor in assess questions is always massively important. So most, somewhat, and least important factors you could also use in that answer. So please use that to redo question 4D if you have been requested to do so. The final question of your IPE for the physical paper was this one, 20-mark question, based on water. And I asked you to evaluate the view that large-scale water management projects often create more problems than they solve for people and the environment. So, building dams, building reservoirs, for example, building water transfer projects. Do they often create more problems for people and the environment, or socially and environmentally, than they solve? You have to take a view on that. You have to argue for or against as you go through. You have to give both sides, obviously. And you have to have a balanced argument where possible. So use a number of different examples. The answer on screen achieved a level 4, 17 marks, so 3 marks off the top 20. And I'm now going to go through very briefly what this answer argued. So it argues that large-scale water management projects are created to relieve water stress or water scarcity. Infrastructures are built in the environment, and that's why sometimes they're short-term fixes. You have to look at their cost effectiveness, and some of them questionably relieve problems. So first talks about reservoirs. And it says that they're beneficial to solve short-term water shortages, but they can also increase biodiversity in an area. However, one of the problems with them is they mess with the natural fluxes and process in the water cycle. This can have impact on the entire drainage basin. Uses an example in the UK, and then it talks about the fact that it can actually have the opposite effect in the long term of creating less water. And then it says, however, on the other hand, on the contrary, large-scale projects are also really, really good for humans, for productivity. North-South water transfer project, for example, in China, has been really effective at transferring water, obviously. But it's also reduced deaths of waterborne diseases by 50%. There's better sanitation, there's a more productive workforce, and it has helped to manage inequalities with water in the nation. So that's a really positive outlook on large-scale projects. Then it goes back to the environment again. It says, however, things like the Three Gorges Dam have been a catalyst for small earthquakes, really damaging to people, made them move from their areas that they live, and therefore can also cause destruction to people and the environment. And then the final argument that this answer makes is it talks about political relationships. And it says that, for example, a dam in Ethiopia there, now you could use the Three Gorges here or the Nile, you could say that it causes political tensions. Now, we did the Nile and we did the Three Gorges dams. You could choose either. And it says that whilst water projects are crucial for economic development and social development, it can cause stresses and strains between people and international government, and that leads to agreements having to be made. So it causes a lot of damage to political relationships, which is social relationships and economic too at the same time. And then finally, it concludes by talking about the many positives, but there are also many negatives. And it ends by saying that sometimes the international relationships outweigh the benefits, and therefore, actually, large scale water projects are a bit of a problem, and they do create more problems than solutions in some cases. So, out of everything I've just said, basically what we're saying here is the candidate has really good knowledge, the candidate has higher level knowledge of large scale projects, very coherent, the candidate considers political relationships, which is a really higher level thing to do, all excellent. The answer tackles all of the factors really well, but the candidate needs to have specific examples of environmental impact as possible. So the candidate sometimes generalizes environmental impact, sometimes doesn't go through those environmental impacts well enough, and just says these all cause environmental impacts. So the candidate needs to be more specific when it comes to the environmental impacts. A reminder, you need a structure in your introduction, your key terms, and your overall view. Your 4 paragraphs then setting out your knowledge, your arguments, your counter arguments. Finally, your conclusion, which sums it up and comes to that decision. So, on the next screen, just like the last 20 marker you had in posts, I've put together for you, and I'm not going to read through this, a structure for how you might want to answer this question. I've used some examples in there that you could use. It's up to you what examples you use, but this structure, try and follow it as best you can, because this is how you access those level 4 higher level marks. When you're going through your answer, try to take as much time as possible in answering it the first time. So if it takes you half an hour to do it or 40 minutes to do it, that's fine. Just spend that time. Make sure you're learning the process as you're going through it. And that is everything for the water section of your IPE. A reminder, what you are doing is redoing the questions that have been requested of you by Mr. Huckle and myself, and that is on Google Classroom as a document for you to see your name and the questions we want you to redo. Please use the PowerPoint that will go up with this on Google Classroom. Please use these recordings. Email me if you've got any questions, but beware, I may have answered them in this, so don't ask me if I've already answered it. Please bring your completed MRI questions, handwritten or printed out, to lesson 2 weeks after the 11th of January. Thank you very much. See you all soon.